Okay, first things first. On your calculator, in the on the top row, in the upper left-hand corner, there is a button called Mode. Press that Mode button. And there's a lot of information on that button. The one we care about is the fourth row down where it says radians and degrees. You should have your calculator on degrees. So go over to degrees and hit enter. Now here's the problem. If you're not in degrees mode, you're still going to get answers. They're just going to be wrong. So, a couple things with that. It wouldn't be a bad idea to continue on a regular basis to see if your calculator is in the correct mode. Also, as a funny joke, right before the quiz, it's always a good laugh to reach over and change your neighbor's mode on their calculator, you know, just for funsies so they get everything wrong. Try it, you know. All right, everybody good? We'll check to make sure it's set correctly later on, but for now, let's get into what we're going to do. Trigonometry is probably one of the most relevant topics we will cover in this class. It is probably the single most used topic in this class moving forward. And it's not that difficult, theoretically. We'll see how it goes. Okay, so what is trigonometry? Well, first thing, everything that we do is based on a right triangle. So we're going to start with something called right triangle trig. In order for it to be a right triangle, you have to have a right angle. Well, what about when it's not a right angle? We will also cover that, but that's quite a ways down the line. So we're going to have to get in the habit of labeling triangles so that we're all on the same page. And so this is the approach that we're going to use. Whatever vertices, I just chose to use A, B, and C. If you'll recall, vertices and points are supposed to be capital letters. This is why it became relevant when it was relevant when I was introducing it, and now you see why it is so important. The vertices are labeled with capital letters. The sides are labeled with lowercase letters on the other side of the triangle. So notice that little a is opposite capital A. Little b is opposite little b. Little c is opposite c. Not every triangle will be labeled like this. If you have a triangle labeled DOG, it's going to look differently, but the process is still the same. Little o will be opposite O, little d will be opposite little d, little g will be opposite capital G. Okay, problems there. Got something for me, Gabe?
Yeah, I got a pass.
Thank you. Questions so far? Beautiful. I don't want that noise. All right, here we go. On your calculator, you will see 3 buttons. Smack dab in the middle. Those are the 3 trig equations, or sorry, trig functions we're going to use. Sine, cosine, and tangent. You will find the buttons that say sin, cos, and tan. Okay, do not call them sin, cos, and tan. They're sine, cosine, and tangent. There are actually 3 other trig values, or trig functions, I'm sorry, that we're not going to talk about. Just these 3. Sine, cosine, and tangent. How many of you have ever worked with these before? Nobody? Excellent. So we're all starting from scratch. Good. We're going to use the KISS method here. You know the KISS method, right? Keep it simple, stupid. Right. The only thing right now that you need to know about those trig functions is that they are simply ratios. Oh, wait. I forgot. What's a ratio? Ella, what's a ratio?
Wait, I know that.
You can do whatever you like. This is America. By far, right on.
A comparison of things?
Good. It's a comparison of things, commonly known as a fraction, right? So we're going to set up a ratio over and over and over again. That's it. If you can do that, this should be a cakewalk. We'll see how it goes. Okay, so here's the definition of each of those trig functions. There's a lot on the screen, so I'll give you time. What's important is not the fractions over on the sides. These are not that important, because if the triangle changes, if instead of triangle ABC, it's triangle XYZ, those will be invalid. What's important is the idea that if we're dealing with angle A, then the sine of angle A is defined as the side opposite over the hypotenuse. From angle A, the opposite side must be A. The hypotenuse is always C. Corey, if I give you a right triangle, how do you find the hypotenuse? No, sorry. Not the value of the hypotenuse. Literally, how do you point to the hypotenuse? Where do you find it?
It's the longest one.
Good. And?
It's on the side.
Doesn't always have to be. It's opposite the right triangle. Okay. So, given a triangle, you should be able to find the hypotenuse. Okay. Longest side or opposite the right angle. The other two sides would be the legs. One leg is going to be opposite. One leg is going to be adjacent. What does adjacent mean? Martha?
Next to.
Next to. Beautiful. So from angle A, we already know where the hypotenuse is. We know that adjacent would be next to, so that's got to be B. And we know that opposite is across the triangle. If you wanted to boil this down, sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. Morning. Or if you wanted to make it even simpler, so ka toa. Okay, so any difficulty in setting up a ratio? Anybody? No? Yes? This is the audience participation part of the program. All right, good talk. Here we go. Are we good, by the way? Everybody caught up? Good. All right. So, here we go. I have a triangle. This triangle is APE. Let's start with something simple. What is the sine of angle A in this particular instance? Julia, let's start with you.
What does like opposite mean exactly?
The side opposite from the angle.
4.
Over.
A.
No. Look at the definition of sine. Sine is defined as the opposite side over the hypotenuse.
4 over 5.
Bingo. Done. Yes, it's just that simple. Ashley, what's the cosine of A? Bingo. Let's stop for a second. Is everybody with us on those? If not, say something. Otherwise, I'll assume you're good to go and we'll move on. Martha?
I'm really confused.
Okay, so if we take angle A, right, because that's what we're working with here for sine, we're going to deal with this angle. From angle A, there are three sides. One of them is the hypotenuse. Which one's the hypotenuse?
4.
No.
Oh, 5.
5. Which one's the side opposite?
4.
Good. And which one's adjacent?
3.
Bingo. Now, that's the hard part. Then, if you look at your definition of sine, sine is defined as the opposite side, 4, over the hypotenuse, which is 5.
I'm confused. So for the cosine, for adjacent, isn't 5 also adjacent to A?
Great question. Everybody hear that? Zach just asked, isn't 5 also adjacent to angle A? And the answer is yes, it is. But it becomes, the priority is it being the hypotenuse first.
Oh, okay.
So once it's identified as the hypotenuse, it can't solve any other purpose.
But what if you were talking about E? Would you do 3 or 4?
We'll get there in a second.
Okay.
Okay? We good so far? Does that help, Martha?
Yeah.
All right, so then Martha, what's the tangent of A? Don't overthink it. Tangent is defined as opposite over adjacent, right? Which side is opposite from angle A?
4.
Good. Which side is adjacent?
3.
3. Set up a ratio, 4/3 done. Okay. Beautiful. Sarah, what's the sine of P? Now we're over here.
3, 5.
3, 5.
Yeah.
3 over 5?
Yeah.
Oh, okay. Sam, what's the cosine of P?
4/5.
Good. And last but not least, Nay, what's the tangent of P? That would be you. Did you forget your name? Say again?
4/3.
Which one?
Oh, 3 over 4.
3 over 4. There you go. Okay, so then Zach asked a very good question. What happens if we're working with the angle E? The sine of E is not bad. Opposite over hypotenuse. Opposite side is 5. The hypotenuse is 5. That's equal to 1. The cosine. Cosine creates a problem because which one is adjacent? Is it 3 or 4? And what happens if we take the tangent of E? Tangent of E would be opposite over adjacent, and again, we don't know which side. So the best way to avoid that and not run into these problems is we're never going to work with, I shouldn't say never, we're seldomly going to work with the 90-degree angle. Everything's going to be the other two angles. By the way, I should have asked this question earlier on. Maddie, what's the relationship between angle A and P? Is that a new quarter zip there? That's gorgeous.
Thank you. It's
Uh-huh.
all sense.
I understand.
Yeah.
The new mask you're wearing today? It's good?
Oh, complimentary.
There we go. Oh, excellent. I knew you'd get there eventually, which means what?
That they added to 90 degrees.
Good. Okay. Since A and P are equal to 90 degrees, that'll become relevant in some of our other calculations. So before I move on, it's important that you get this. If you don't, then what I do from this point on is going to get more confusing. Do you need me to go over this at all? Is everybody good? Yes? Okay, don't question.
Could you like have like a short summary of the
Anytime we deal with an angle, you have to identify which side is opposite, which side is adjacent, and which side is the hypotenuse. I'd actually go in the reverse order. I'd find the hypotenuse first, then the opposite side, then the adjacent side.
Okay.
Then it's just a matter of fitting into those ratios.
Okay.
Okay, so like for instance, if I ask you for A, sine of A, when we did this, I need to go from A, I need the opposite side. Well, I go across the triangle to get 4. 5 is the hypotenuse, I get 4 over 5. Okay?
Yeah.
We're good? Question?
May I get a tissue, please?
Yeah, you don't have to ask, just here. Catch. You can just get up and grab a tissue, it's all right. Because if you don't, it's going to like fill your mask in. All right, let's make sure your calculators are working correctly. Simply hit the cosine button, remember not the cos button. The cosine button, hit cosine 41, enter. .7547095802. Are we all good? Yes? If you are not good, you need to say something now or this is going to be a bad experience. All right, check the tangent of 74 just to be sure. .48741444444.
Nope.
No.
Oh, I got -5.
Oh, you weren't here. Hook them up, Sam. There you go. Okay, beautiful. And then do the sine of 2 degrees, just for giggles. And you should get .034899497. Yes? Excellent. We're all on the same page. If you loan your calculator to somebody, check the mode. If you have a brother or sister that you share a calculator with, especially if they're an upperclassman, check the mode. For instance, my calculus students are never in degrees mode. They're always in radians. Okay? If your calculator leaves your site, check the mode. I will not remind you before a quiz to check the mode. It's on you. And again, remember that trick about changing your neighbors, because that's always fun. Okay, so now we're going to use trig to solve problems. For instance, I have this picture. We're going to go slow. I'm going to walk you through the first one, and then I'm going to let you solve the others. It goes something like this. I look at this problem, and I know that I'm working with this angle down here. Let's call it angle capital X, because I've got X over there. We'll call this Y, and we'll call this Q. Just to be, could have gone with Z, but you opted for Q. Okay, beautiful. I'm going to solve for X first. I know angle X. So the first question I would ask myself is, from angle X, is this 3 the opposite side, the adjacent side, of the hypotenuse? Opposite side, adjacent, hypotenuse. Hypotenuse. Okay. How do you know? It's across from the right angle. It's the longest side of the triangle. Okay. Is the X the opposite side or the adjacent?
Opposite.
Opposite. Beautiful. Okay, so to solve for X, I'm using the hypotenuse and the opposite side. Which function uses the hypotenuse and the opposite side? Which one? Sine. Correct. Okay, so I've done all the hard work. Now I set up an equation. The sine of 40 degrees is equal to X over 3. Anytime you have one of the trig functions, sine, cosine, or tangent, you have to be taking the sine, cosine, or tangent of something. And it should be an angle measure. You cannot take the sine, cosine, or tangent of a side. It's got to be an angle. All right, so questions before I continue? It's the angle measure. Good question. Anything else? Okay, solve for x. How do I solve for x? I multiply both sides by 3. Wow, that's weird. I'm going to put the 3 out in front. Why do I put the 3 out in front? Because if I don't put it out in front, some of you are going to turn that into the sine of 120, and that would be bad. Get that out of there. I don't know where that came from. Okay. Plug and chug and tell me what x is. Can I get a confirmation, please?
Yeah.
1.92. Vic, let me ask you a question. Is that a reasonable answer?
Yeah.
Good. What would not be a reasonable answer?
Anything over 3.
Good. Or? The or is so bizarre you probably wouldn't even think of it. You could get a negative answer.
Oh.
If your calculator's in the wrong mode, you might get some negative answers. And remember, negative answers for distance is never a good idea. Okay. Now, when you get that answer, you want to store it somewhere because we might use it for a calculation later. Hit the stow button on the left-hand side and store it, I don't know, into x. From this point on, you have 2 ways to solve for y. One way would be your friend and mine, Mr. Pythagorean theorem. However, we're going to solve it using trig because we need the practice. Okay. We still know the 3. Now we're using the y. I'm going to stay with angle x because I know that information. 3 is still the hypotenuse. Y becomes the adjacent side. Which function uses adjacent and hypotenuse? Cosine. Set up an equation. Okay, what's y? $2.29. Confirmation? Okay, we're good. 2.29. If you opted to use Pythagorean theorem, you would get the same answer. So at some point, you're going to have to decide what you want to do. If you really love Pythagorean theorem, then you can solve for y using Pythagorean theorem. However, I would recommend staying with the trig because you're going to need practice with the trig calculations. You also want to understand what you're doing. So the question that I asked Vicky earlier is, does that answer make any sense? You need to be able to recognize if an answer doesn't make sense. If all of a sudden you have a hypotenuse, all of a sudden if you have a side that's bigger than the hypotenuse, you screwed up somewhere. If you get a side that's negative, you screwed up somewhere. You can't have that going on there. All right, questions before we move on? We're good? You think? Okay. Here we go. Let me get this stuff out of the way. Here's one for you. All right, I'll help you out here. We'll make this R. we'll make this S, and this one we'll call it T. Okay, solve for R and S. Go. You might want to ask your table mates to help you out. Or you might want to help your table mates. Want a cup of coffee or something?
Oh, good. I forgot my calculator was gradients though, so I've been using it, and I was like, why is the trig not working? That would be it, because I'm taking geometry and measurement right now. And I'm like, I know I'm doing this right, and I'm getting negative answers, so I've been doing it by hand.
Oh, by hand. Ridiculous.
Okay, what do you think this is? I did sin equals r, sin 15.5 equals r over 35, and then I did for sin 15.5 equals r. So then r equals 9.34.
So if we're looking at the angle,
Opposite and adjacent.
It's R.
Is that okay? I can solve.
You guys don't know R. It's a big problem.
Oh, by the way, where's the hypotenuse in this triangle?
35.
S, not 35. Also, while I have your attention, let me show you how, this is my hall pass that we haven't been using yet, but on this hall pass, this used to be a desk cover. There is a list, all of this is a trig table, which is what your calculator does. So back in the old days, when we wanted to take the sine of 75 degrees, you had to look it up on a chart because we didn't have calculators. You kids don't know how good you got it. Imagine carrying a desktop around with you. Carry on.
I have a question.
So if I wanted the sine of 45 degrees, I'd get 0.7071. Type in the sine of 45. Yeah, right there. 0.7071.
I need to find R.
That's very
Oh, so if you find R, we look for that.
How do you solve for the sin if both of them are if don't do that? Because I thought that if R is if S is the hypotenuse, then how do you do like how do you write it? R over S? I mean,
Yeah, you can't solve that though. So you gotta do a different one.
different what?
If you do 10 R equals R over 35.
There you go. What?
So, what do I do?
Pick a function. What do you want to solve for? R or S?
Okay, I thought this was the sin now.
You already know what big R is. It's 15.5. little r, the opposite adjacent hypotenuse.
Of what?
That angle that you want. Good. And is the 35 the hypotenuse or the adjacent?
No, adjacent.
Adjacent. What function uses opposite and adjacent? Good. Tangent. Set of equations.
That's why I'm so I don't think I
You can't find a trig equation. You could just good answer.
Because if you're trying to do it from the 15.5 angle, the plane is opposite adjacent. And opposite from 15.5 is R, so if you're trying to solve R, it's opposite, and then the hypotenuse is adjacent. Opposite adjacent. So R would be good.
Well, the opposite is
No, that doesn't sound
or
Okay, I'm trying to find R. R is opposite to start out. And then what is 35? 35 is adjacent, opposite adjacent. R and 35.
How do you find the sin? It's
Wait,
just
how do you solve it though?
Is it just
Okay,
okay, you need to find the just side.
for the R, yes.
Which is it just
In the cafeteria.
Which is good, because it's got to be bigger than 35, right?
Like
Solve it. S is equal to
yeah, no,
Make any progress?
you would solve for R.
You don't have to use can, right? Because you only solve
You can use whatever you want as long as it fits into the scenario. No, not yet.
So where'd you get the line on others?
Multiply both sides by 35. I'm not going to spend time doing that. Welcome to geometry.
R equals 3.9.
I got the sin
Yeah.
What did you get for R?
This is
TOA.
for the opposite of R.
Okay, we got a lot more to go, so let's work through this. I'm going to solve this one again, but I'm going to talk through what I'm trying to do in my head. Hopefully that'll help you set it up. So a lot of mistakes that I saw is, number one, you didn't identify the hypotenuse correctly. Okay, S is the hypotenuse. That means when I get an answer for S, it better be greater than 35. Okay? So that's an indication of I did something right maybe, or I did something wrong maybe. first step I do is look at the given information. I know I have that angle of 15.5, and I know I have this side. So I'm going to be working with the angle R. Okay. Angle R is 15.5. So I'm going to solve for side R first. I don't have to. I could solve for S first. I'm just choosing to do R first. I know that I'm looking for R, and I know that that's 35. This is the hypotenuse, this is adjacent, this is opposite. So I'm going to work with the opposite side and the adjacent side. What function uses the opposite side and the adjacent side? Now, at this stage, you're going to have to scroll back up and see, oh yeah, let's see. Tangent is opposite over adjacent. Eventually, it will burn into your brain and you don't have to think about it more. Tangent of some angle measure is equal to the opposite side over the adjacent side. Questions? There are other ways to do it, but that's how I'm going to choose to do it. I'm not going to spend time talking to you about how to solve this because you're all pretty bright and should be able to solve this anyways. What was it? 9.7? 9.70. Let's go 2. Okay, good. Okay, easy. Questions? Now, how to find S. I could do 9.70. Actually, I wouldn't use 9.70. I'd use the stored value for R squared with 35 squared equals S. But I want to do it using not using Pythagorean theorem. So I'm going to erase this and start over. Put that R back there. Okay. I'm going to solve for S. I have the angle still, so I'm still working with R. I have the adjacent side, and I'm looking for the hypotenuse. Adjacent and hypotenuse becomes a cosine function. Set up my equation. The cosine of the angle is equal to the adjacent side over the hypotenuse. That cosine and that 15.5 cannot be separated. You can't do things like divide both sides by 15.5 to just have the cosine sitting there. That makes no sense. They're attached. Some of you struggled with solving for S. This is the one time I'll show you. I need to multiply both sides by S, and I get S times the cosine of 15.5 is equal to 35. Then I need to divide by the cosine of 15.5. That's commonly referred to as the switcheroo. Why the switcheroo? Because this is switching with that when your unknown is in the denominator. Plug and chug into your calculator. What's S equal? Does that answer make any sense? I don't know what just happened there. Why won't it draw 3? Okay, we're going with it. Vic, does that answer make sense?
Yes.
Yeah, because it's bigger than the... Whoa. That was cool. Where's my clicker? I don't know what just happened, but... Thank you. There it goes. Okay. Problems? Questions?
I'm just confused on how you put letters into the angle, into the triangle. Like, why do you choose to add more?
So I can identify those vertices. Unlike these other triangles where I told you where the vertices were, or how they were labeled, I needed to be able to refer to the vertices. So I just labeled them according to capital R would be opposite side R, capital S would be opposite side S, and then I just called that guy T for no particular reason. Okay, how are we doing so far? Brains ready to explode? Cool, then this is going to get worse. One thing we haven't talked about is how big are the angles? I'd like to know how big angle P is. I'd like to know how big angle A is. And the nice thing about it is, based on what Manny told us before, if I can find angle A, then I can easily find angle P because those two angles add up to 90 degrees. To do that, we're going to use something called an inverse function. What is an inverse function? What's the inverse function of adding? Subtracting. What's the inverse function of multiplication? Division. What's the inverse function of squaring? Square root. Good. All right, so the inverse functions for trig values undo the trig equations. You'll find those above the sine, cosine, and tangent buttons. Look at your calculator. It says cosine to the -1, sine to the -1, tangent to the -1. Okay? And again, it undoes the trig functions. If you understand that, hopefully this will be a little bit easier. So in this problem, we talked about angle A, and we said the sine of angle A, we did this earlier, the sine of angle A was 4/5. So I ended up with this equation. I forget who helped me with that, but it doesn't matter, we're there. Now, what I do, I kind of skipped there, and since we're going slow here, I'm going to show you what I do. Sine of angle A is equal to 4/5. I like to leave a gap there, because I'm going to undo the sine function. To undo the sine function, I have to do the inverse function. That's not good math. Whatever you do to one side of the equation, you have to do to the other side of the equation. These two cancel out, whoopsh, whoopsh, and leaves, and that's how I got to that step. Then this, you type in your calculator. Not the sine function, that's an inverse sine function. So inverse sine of 4 divided by 5, close parentheses. Parentheses become important here. And you get 53.13. Can somebody confirm? Okay, so angle A is equal to 53 point, you said 13? Yeah. 13 degrees. I don't have to do any trig to solve for P, because all I'm going to do is take 90 minus that answer and get I'm assuming somebody's doing that calculation, right? Or am I just standing up here staring at nothing?
36.87.
36.87. Okay, done. After that little bit of work, I now have all the information in the triangle solved for. I know how big all three angles are. I know how big all three sides are. That, in fact, is called solving the triangle, finding all 6 parts. We good? This will be the last one we solve, I think. I didn't give you any information. Sorry, let me rephrase that. I didn't draw a picture. So you're going to have to draw a picture on your own. I'll draw it for you. Is this A or B? You want to make it B? Sure. Okay. How long is this side? Hello? How long is this side?
18.
Nope. Nope. Do you know how long this side is? No. So what should we call it?
Lowercase.
Lowercase c. How long is this side?
Lowercase.
No.
13.
18, good. And that makes this side 13. Okay, so far? Okay, that doesn't do anything for us except give us a picture to work with. And I have to solve for 3 things. In order to solve the triangle, when I'm done solving the triangle, I have all 6 components. I have 3. I need 3 more. Devin, what would you like to solve for first? Would you like to solve for angle A, angle B, or side C? There's no wrong answer, by the way. I gave you an easy one. Angle A. Awesome. A for awesome. Okay, Devin. If I'm solving for angle A, and first of all, let's back up. From angle A, I'm assuming you realize C is the hypotenuse.
Yeah.
Good. Is 13 opposite or adjacent? From angle A, is the side 13 adjacent or opposite? Opposite, good. Which makes 18? Good. What function uses opposite and adjacent? No? 1 down, 2 to go. Tangent, good. Questions so far? That's the hard part. Now, I just set up an equation. The tangent of angle A is equal to, I'm going to leave some space here. Devin, 13 over 18 or 18 over 13? Gesundheit. Perfect. Okay, let me stop there for a second. Everybody good? Now, why did I leave a space there? Because I want to get angle A by itself. To get angle A by itself, I have to do an inverse tangent. If I do an inverse tangent there, I have to do an inverse tangent there. Cancel, cancel. Plug and chug. Angle A is equal to, what is the inverse tangent of 13/18, please? You should be doing this on your calculator, by the way, for practice.
35.83.
I have a 35.18, you said?
83.
83. 35.83, can somebody confirm? Yes. Okay, good. 35.83. I'm not going to do trig again. I'm just going to take Sarah's answer and subtract it from 90 to find out angle B. And you can just do 90 minus answer. And get?
54.16.
50, whoa, that's a horrible 5. 54.1, should be 17, I think, based on that answer, right? Okay, good. I got that, I got that. I only need one more chunk of information. Devin, back to you. To solve for to solve for the side C, what would you like to do? Would you like to use trig, or you just want to go with the old standby Pythagorean theorem? Trig? Oh, love it. Okay. Do you want to use angle A or angle B? Angle B, no problem. Okay, so if we use angle B, I know I'm looking for the hypotenuse. So, Devin, you have a veritable plethora of options. Do you want to use the 18 or the 13? 13, great. Is the 13 from angle B opposite or adjacent? Good. We're looking for the hypotenuse. What function uses adjacent and hypotenuse? Good. Cosine of 54.17 is equal to 13 over C. Adjacent over hypotenuse. Do the switcheroo. C is equal to 13 divided by the cosine of 54.17, which equals, a little help please. And I know already I should get an answer greater than 18. If I don't, I did something wrong. Or you typed it into your calculator wrong. Madeline, you got it? 22.2, can somebody confirm?
How do you write that in a calculator?
How do you do what?
How do you write that in a calculator?
13 divided by the cosine of 54.17.
Oh.
Yes? 22.2? Okay, good. This is not degrees because it's a side length. And I didn't give you units, so you're good to go. Martha?
How did you find B?
How did I find B?
Yeah.
Based on what Maddie told us earlier, A and B are complementary. They add up to 90. So once we knew A, we just took 90 minus the value of A to get B. Okay? All 6 parts now. A, angle B, angle C, side A, side B, side C. Done. Okay? Questions? I know it's a lot. Your brain's about to melt. That's okay. You'll be fine. Let's see what's next. I think I might have one more example for you. Oh boy. Let's see. Oh! Holy guacamole. What?
It's not.
You're standing 100 feet away from the flagpole. The angle up to the top of the flagpole is 37.5. If your eye is 5.5 above the ground, how tall is the flagpole? Crikey. Flagpole. $48, $49, $50. Good. Okay. Here you are. You're loving geometry. And your mouth just went all freaky. And when you look up to the top of the flagpole, oh, wait a second. You're also 5.5 feet tall. That's 5'6", by the way, not 5 feet 5 inches. Because there's 12 inches in a foot. Now, it would be easier from a mathematical approach for you to do this by laying down and putting your eyeball on the grass. Okay. Because if you did that, we wouldn't have to deal with this 5.5 garbage. Do you want to lay your eyeball down in the grass?
No.
No. Okay, so how long is this?
5.5.
5.5. Very good. We're looking for this distance, x, and we know that this is 37.5 degrees. Okay, so we're going to set this up. I'm not necessarily going to solve it. We're just going to work our way through it. Because the important part to figure out in this problem is, what function are we going to use? We know for some weird reason that we're 100 feet away from the flagpole. I guess we counted that off. Okay, so from the 37.5 degree angle, Michael, is x the opposite, the adjacent, or the hypotenuse from that angle?
Opposite.
Good. Is the 100 adjacent or hypotenuse?
Adjacent.
Good. So we don't care about the hypotenuse in this case. What function uses opposite and adjacent?
Tangent.
Good. Tangent of 37.5 is equal to x over 100 or 100 over x, Michael?
It would be 100 over x, or x over 100.
There you go. Okay, we're going to stop there. You can solve that for x. That's not hard to do. But you got to remember, in this case, you need to add the 5.5 to it. The problem will change depending on where your eyeball is. If your eyeball is laying in the grass, then you just set up a triangle and everything is grand. Because you're being a little bit more humane about it and standing up, like most humans should, because it would be just weird to stick your eyeball down in the grass, then you need to add 5.5 to the end of that problem. Okay? Lot of information. Now, I'm kind of taking a shotgun approach here, meaning I've just blasted you with a bunch of information, and then you're going to get in there and get your hands dirty and start solving these problems. I've given you enough checks and balances to be able to look at a problem when you're done and say, yeah, that might not be right. Like, for instance, in this problem, if you solve that and you find out that the flagpole is 3.5 feet tall, you probably did something wrong. If you do the calculation and you find out that that flagpole is 8,271 feet tall, you probably did something wrong. The real world problems are not too bad. The non-real world problems where you're just given a triangle, I've shown you things like making sure that your answers for the legs are always less than the hypotenuse, or another way to look at it is that the hypotenuse is always bigger than the other legs. And also when you're done, make sure that your angles match up. Okay, I know, just from what we talked about earlier, how big this angle is up here. I could find that angle if I was looking for it. I don't know why I'd want that angle, but I could find it to be 52.5 because I have to add up to 90. Okay, questions? Beautiful. Yeah, we'll skip that one. Okay, day 2 on the homework. What I would suggest is you get this done as quickly as possible. Get it done today, turn it in, and forget about it. I would love for you to not do anything over Thanksgiving break. Get it done today. If you have to, do it tomorrow, but by all means, done by Tuesday at the end of the day so you walk out of the building tomorrow with no math homework. Okay, then take a couple days off, and then when we come back, I will see you again on Monday. When we come back, we'll pick up where we left off. I'm sure you're going to have some questions, but you have to get in here and try these problems. Okay, if you leave them blank, you won't learn anything. Because what will happen is you'll come in with it blank, you'll look at your table mates, they will have gotten it, you'll copy it down, and there's zero learning going on. And as I said at the beginning, this is one of the most important topics that we cover in this class. If you do nothing in this class, you need to come out of here knowing how to solve trig problems.